İzzet Yağizefe Sungurlu. In this experiment, I will use a spring, a puck, an air table, and a paper. In this experiment, we assume to convert the spring potential energy to kinetic energy. We will apply we assume friction is zero, and we will apply some compressions, five different compressions to pack on spring, and we will calculate the velocity of the pack using the dots on the paper. After calculations, our aim to observe the conservation of energy and drawing a plot for with using our data.
In the experiment, I choose 5 different points with different compression amounts, and I release the puck. After the experiment, I measure and calculate the velocity with black dots on the white paper to find the conversion of spring potential energy to kinetic energy. In the data part, I fill the displacement and average velocity tables for 5 different compression amounts as 1, 1.5, 2, 2.5, and 3 centimeters by using the data from the experiment part. After filling the tables and finding the average velocities of the puck under different compressions, I calculate the spring constant. Also, by using the energy conversion formula, I draw a graph of mv squared divided by x squared and best fit line in the Python to get the spring constant as a slope of graph. Except some deviations, we get a linear plot because of the formula has square roots in both sides of the equation. Even though the experimental results show a consistency with expected values, there are some deviations in 1 cm compression. The deviation is the result of the littleness of the compression amount for the collecting data. Also, error rate of this experiment is calculated as 3.45%. The errors arise from the observation errors, friction of air table, sensitivity of the measurement, and the change in the spring during the experiment because of the compression and stretching.